Assalamu alaikum, dear students. How are you? I think all of you are well in this pandemic situation. I am also fine. I am Hiron, Associate Professor and Head of the Department, Statistics Department, Eden Mohila College, Dhaka. Welcome to all of you on behalf of Eden Mohila College online class. Today's topic is various steps for testing hypothesis. Second year non-major course statNM 202 Principles of Statistics. Earlier I have discussed testing hypothesis, or null hypothesis, alternative hypothesis, type 1 error, type 2 error, and various definitions. Today I shall discuss various steps involved in testing hypothesis. Various steps involved in the solution of testing hypothesis problem may be outlined as follows. Number 1, explicit knowledge of the nature of the population distribution and the parameters about which the hypotheses are set up. Explicit knowledge of the nature of the population distribution and the parameters about which the hypotheses are set up. Number 2, setting up of the null hypothesis H0 and alternative hypothesis H1. Setting up null hypothesis H0 and alternative hypothesis H1. Number 3, fix up level of significance alpha. This is level of significance. In most cases, it may be 0.05 or equal to 0.01. Number 4, the choice of suitable test statistic will best reflect upon the probability of H0 and H1. Number 4, the choice of suitable test statistic will best reflect upon the probability of H0 and H1. Number 5, partitioning the set of possible values of the test statistic T into two disjoint sets W and W bar and forming the following test. Number 1, reject H0 if the value of P falls in W. Number 2, accept H0 if the value of P falls in W bar. Partitioning the set of possible values of the test statistic T into two disjoint sets, that is W and W bar, and forming the following test. Number I, reject H0 if the value of T falls in W. Number 2, accept H0 if the value of T falls in W bar. Number 6, After performing the above test, obtained experimental sample observation, compute the appropriate test statistic and take action accordingly for making decision. After performing the above test, obtain experimental sample observations, compute the appropriate test statistic and take action accordingly for making decision. Okay, this is the test various steps involved in testing hypothesis. Again, number 1, explicit knowledge of the nature of the population distribution and the parameters about which the hypotheses are set up. Number 2, setting up of null hypothesis H0 and alternative hypothesis H1. Number 3, fix up level of significance alpha. In most cases, it may be alpha equal to 0.05 or 0.01. Number 4, the choice of suitable test statistic will best reflect upon the probability of H0 and H1. Number 5, partitioning the set of possible values of the test statistic T into two disjoint sets W and W bar and forming the following test. Number 1, reject H0 if the value of T falls in W. Number 2, accept H0 if the value of T falls in W bar. Step 6. After forming the above test to obtain experimental sample observations, compute the appropriate test statistic and take action according for some making decision. Some important test of hypothesis. Important tests of hypothesis. Our important test of hypothesis are normal test, t-test, f-test, chi-square test. That is chi-square. Chi in Bengali meaning chi borgo. This is chi-square test. Our important some important tests of hypothesis are normal test, t-test, f-test, chi-square test. Normal test. If sample size large, if n large, that is n is greater than 30 and sigma is known, then we can use normal test. If sample size n is large, that is n is greater than 30 and population variance sigma square is known, then we use normal test. It is denoted by D or Z. It is denoted by D or Z and given by Z equal to x bar minus mu 0 sigma root over n. This is follows x bar minus mu 0 sigma root over n follows standard normal distribution with mean 0 and variance 1. This is normal test. When we use it, when we use normal test to test single mean, to test two independent sample mean, to test sample proportion, to test two proportion, to test single correlation, to test equality of two correlation, to test single mean, to test two independent sample mean, to test sample proportion, to test two proportion, to test single correlation, to test equality of two correlation. Next, t-test. Number 2, t-test. When the sample size small, that is n less than 30, sigma is unknown, then we can use t-test. When sample size is small, that is n less than 30, and sigma is unknown, then we can use t-test. The formula is t equal to x bar minus mu 0 l divided by for n follows t n minus 1 degrees of freedom. There s square equal to 1 by n minus 1 summation x square summation x whole square by n. When we use t-test, sample size small, variance unknown, then to test population mean, to test the equality of two means, to test a specified value of correlation, to test sample regression coefficient, to test for paired observation. Sample size small, variance unknown, then to test population mean, to test the equality of two means, to test a specified value of correlation, to test sample regression coefficient, to test for paired observation. Chi-square test. Number 3, F test. F is defined as the ratio of two independent chi-square variance divided by their respective degrees of freedom. That is chi1 square n1, chi2 square n2. This is F test. F is defined as the ratio of two chi-square variance divided by their respective degrees of freedom. When we use F test to test the equality of two population variance, to test the equality of several means, to test the significance of an observed multiple correlation coefficient, to test the significance of observed sample correlation ratio, to test the linearity of regression, to test the equality of population variance, to test the equality of several means, to test the significance of an observe multiple correlation coefficient. To test the significance of an observed sample correlation ratio, to test the linearity of regression. Next, chi-square statistic. If xi follows normal distribution with mean μi variance sigma square, then chi-square statistic equal to summation xi minus μi by sigma whole square. It follows chi-square distribution with n degrees of freedom. If xi follows normal distribution with mean μi and variance sigma square, then chi-square equal to summation xi minus μi by sigma whole square follows chi-square distribution with n degrees of freedom. When we use chi-square statistic to test the specific variance of normal distribution, to test the goodness of fit, to test the independence of attribute, to test the homogeneity of several variance, to test the homogeneity of several proportion, to test the homogeneity of correlation, several correlation coefficient, to test the specific variance of normal distribution, to test the goodness of fit, to test the independence of attribute, to test the homogeneity of several variance, to test the homogeneity of several proportion, to test the homogeneity of several correlation coefficient. This is our important test statistic and there are uses. Now I shall discuss mean test. Mean test. There are several mean tests. Single mean test or test for a specified value. Specified value. Single mean or specified value. Two mean test. Several mean test. Test for a specific pair. Test for paired observation. Test for paired observation. Mean test, single mean test or specified value. Two mean test, several mean test. Test for paired observations. Single mean test or test for a specified value. Assumption. We can assume that the samples are drawn from normal distribution. With mean, mu and variance sigma squares. Number 1. Number 2, population variance sigma square is unknown and sample size n less than 30. This is assumption. Next, hypothesis. we set up hypothesis, null hypothesis, mu equal to mu 0, a specified value. Alternative hypothesis, mu not equal to mu 0, or it may be mu greater or mu 0, mu less than mu 0. This is alternative hypothesis. May be mu not equal to mu 0, mu is greater than mu 0, mu is less than small. At first assumption, then hypothesis, then test statistic. Test statistic. If sample size small, variance unknown, then we can use t-test here. x1 minus mu 0 is divided by root over n follows t n minus 1. Then comment. If calculated t is greater than tabulated t at alpha percent level of significance, we may reject a 0, otherwise accepted. If calculated t is greater than tabulated t at 5% level of significance, alpha percent level of significance, we may reject a 0, otherwise accepted. In single mean test, if sample size large and sigma is known, sample size large, sigma is known, then we can use z test. Then we can use z test. And z 5% level we know 9.6. This is fixed. This is fixed value. Z 5% 1.96. And then comment. And then comment. If calculated z is greater than tabulated z at 5% level of significance, then we reject null hypothesis, otherwise accepted. This single mean test. Next, two mean test. Two mean test. Here assumption, two random samples of size n1 and n2 are drawn from two normal distributions. The two samples are independent. Sample size small, population variance are unknown but equal, then such a case we can use t-test. Here assumption, number one, two random samples of size n1 and n2 are x1 n1 mu1 sigma 1 square, x2 n2 mu2 sigma 2 square, and number two, these two samples are independent. Number three, population variance sigma square, sigma 1 square and sigma 2 square are unknown but equal and estimated from small sample and less than n1 and 2 less than 30, then we can our assumption this test hypothesis. In this case, the appropriate hypothesis is mu1 equal to mu2, alternative mu1 not equal to mu2. Test statistic. The appropriate statistic is t x1 bar minus x2 bar is divided by yn1 plus 1 by n2 follows tn1 plus n2 minus 2. This is test statistic. Here s square equal to n1 minus 1 s1 square, n2 minus 1 s2 square, n1 plus n2 minus 2. And from table t alpha percent and degree of freedom, we can get a value from the t table and then comment. If calculated t is greater than tabulated t at 5% level of significance, then we may reject null hypothesis, otherwise accept it. If population variances are equal but known and estimated from large sample, then we can use normal test, that is z equal to x1 bar plus sigma root over 1 by n1 plus 1 by n2 standard normal. This is sigma 1 square sigma 2 square by n1 by n2, and we know that 5% equal to 1.96. In this case, we can use when population variance are unknown but equal but known and estimated from large sample, then we can use normal test, which is this, and we know that 5% equal to 1.96. Next, as usual comment, if calculated z is greater than tabulated z at 5% level of significance, then we may reject null hypothesis, otherwise accept it. So viewers, no more today. Inshallah, another day I shall discuss the rest of mean test, variance test, correlation test, etc. So best of luck. Thank you all.